In the
All
corner
right, so
quietly.
yeah,
Cool.
well then don't be talking then.
Okay,
Stop
cool.
talking.
Starting now.
No, let me give you a starting point. Starting now. All right, so atheist, what do you think the shape of the earth is?
I think it's an oblate spheroid.
Cool. All right, why do you think that? Do you have any information to support that?
Well, um, the International Space Station has a 24/7 video feed of the Earth that shows its curvature. I don't know if you want me to give more than one example, but we have the photos from NASA, and also you can calculate it based on math using mathematics. And if you're, if for example, on a lake, and you can measure the curvature of the Earth. I'm not really good with all that math, but I've seen it done. And also the fact that ships go over the horizon from bottom to top when they go. So I guess those would be my reasons.
Okay, let's go with the first one. So
Okay.
you said the ISS, right?
Yeah.
Okay, so the information that you receive is through a medium of a video or images. Is this correct?
Yeah, it's a live stream video.
Okay. What is the verification process that we can do as individuals to see if that information can check out as what they're saying it is? How can we know that that's true what they're showing us? In the case of like somebody showing you a image of, let's say, a rare butterfly, right? You could actually find out whether or not that rare butterfly is a thing in existence or something Photoshop. Would you agree or disagree on the case of the butterfly?
If it was a photo,
Hmm.
um,
If it was a rare butterfly you've never seen before, and they showed it to you, and they're like, "Look, this thing exists." What could you do to verify if that butterfly exists in this reality or not?
well, I could check it against a database of species of butterflies that have been discovered, or and see look on the internet if there are other photos of that same butterfly, same pattern, same genus and species name. Um, yeah,
Interesting. So you could give a lot of relevant information as to why, or a strong inference as to why this butterfly could exist, right?
yeah.
Okay. But what would be the place where you could say, I know it actually exists versus I believe it exists? Because
Well,
you could say, I believe it exists based upon all the inferences you could make from evidence leading you to it. But how could you say, I know it exists?
well, if I saw one in front of me, that would be probably the best way. But I know that if I see, we're talking about a photo, right? I know that if I'm shown a photo of that specific butterfly, and I first of all, it would depend. It would I would like to know who the person showing it to me is, and what the source was of the image. But if I did research to confirm that I think it does exist, then I would know that that specific butterfly is part of a population, and that one, even if it's dead, that species of butterfly does exist. If I was able to confirm that, that's how I would know.
Yeah, there's a part of working with things in our tangible reality where we can actually say and verify the thing that was done like an image of a butterfly that was rare, and we wanted to see if we could uh, test that knowledge claim of that. We could work with the maybe one that was a dead butterfly, or perhaps seeing some in the wild, but there could be something that we could do to verify that butterfly exists, as per the case of having somebody take an image of it, right? So picture or whatever. But what I'm saying is, there's a way that we can get to the part of knowing where we can experience this butterfly ourselves. We can know that it exists. We can work with it. It's not just an image. It's not just an inference. It's not just information gathered from other species. But we can say we know it exists because we can work with this butterfly in its natural environment, or we can experiment with it, right? That's things we can do. Would you agree or disagree?
Well, I'm not sure if I would agree. Are you saying that you would have to see it in front of you to confirm that it exists?
No, the knowledge claim that the from the knowledge base of saying I know that this butterfly is something in existence, rather than it being an inference. So when you don't have the experience of working with this thing in tangible reality, you have just a belief based on an inference that you have that it does exist. So do you see what I'm saying? You could correlate things to say like, well, we know that other types of butterflies like this exist, but we don't know that it actually does until we experiment or we do some tests with them, see them in their natural environment, and work with them essentially.
Right.
So when you have that experience, you gain a knowledge base that's uh it varies from saying that I somebody shot me a picture and I know from the other types of butterflies that this one butterfly exists based on the my knowledge base of the other ones that I know. So you start to become someone who can verify and or falsify the image by saying, you know what, this guy who took the picture, I went to go investigate whether or not this butterfly exists. I see them flying around their natural habitat, and I can test one. I can see its wingspan, and like you worked with them, so you, in tangible reality, you can verify that that butterfly does exist. So an experience is paramount, or I would say supersedes the belief or inference that you had prior.
Sure.
What I'm making a case for is that it becomes something that you can say, yeah, I've worked with these things. That's what I do. I work with these insects, and this one here, I know it exists because I worked with it. I literally measured its wingspan, and like you can do things that you couldn't do if you hadn't had that experience. An inference will only take you so far, but an actual knowledge base where you've gained from knowing that you've worked with these insects will had then put it into a level of knowledge that you didn't have prior to that. And so the same goes for, and I'm making a strong case for an analogy to the ISS. When they show you things and you start putting together some type of belief that you have of the ISS and viewing things on the live stream, images and so forth are only going to get you to that strong inference, but they're never going to give you that verification or a knowledge base that you would have if you had an experience working on an ISS, let's say, or going to it or being there or knowing the equipment they're using or anything. You can only know it from a secondary hand information. So it's hearsay at best at this point. They're showing you things, they're telling you things, but they're not giving you that experience, and you don't have that. So you could only say, based on an inference, that you think that the ISS is true on what you've been shown,
Do you
and
think
that's
that
as good as it gets.
do you think that the ISS is actually in space? And do you think that the video feed is accurate and it's a real video feed?
Yeah, according to the people that are talking about where it is, it's up in the upper part of the thermosphere, so below the exosphere. And where it is considered to be the acronym of LEO, which is low Earth orbit. So they're saying that and there's a lot of there's a lot of attributes that are a part of it, right? How fast it's going, how long it's been up there, how what's the capacity? Like there's a bunch of things attributed to that. So there's a bit of lore attached to it. So when you start to figure out, okay, so they're telling me things that I don't know if it exists or not, but here you go, right? It's traveling at 17,500 miles per hour. It's made of a specific type of material that can, reflect the heat that it's, where, of course, being in the thermospheres, it's around these temperatures that are really hot. So there's things that they're telling you about it, and you're just accepting based on the information. You don't have any way to verify these things,
But
right?
you can look up in
So
the sky and see it.
yeah, there's that, right? You could see
You can
something.
see it with the
You're not
naked
see
eye
Yeah,
from
no,
Earth.
you're not seeing it with the naked eye.
No,
You
you can
see
see. You
something.
can literally see the ISS in certain
Can
countries.
you see
You
this?
can see it
Yeah,
with the naked eye from ground level.
yeah, you see something. I'm not gonna lie to you. There's something that they call the ISS, but it's not what you might think that carries humans around in that thing. So once you can actually go there and see inside and be like, look, I traveled to the thing they call the ISS. I've been inside. I've experienced all this. This is my experience. Then you can say that. But from a distance, you could say I saw something that they're telling me is the ISS. So even if you see something, it's not verifying the thing that they're telling you is an actual vehicle which carries humans.
Yes, it
That's
is.
no, that's what your inference is about.
No, I don't think
You've
you
never
answered my
been
question
there.
though. Do you think that the ISS is
Yeah.
actually in low Earth orbit? Do you think it's real?
It's above something that's above us that they call the ISS is there. It's not what they're telling you it is, like a
What is it
vehicle that
then?
carries humans.
What is it?
It could be some type of technology, but it's not what they're telling you.
Then what is it?
Who knows, dude? Nobody knows.
I
Like
no, I
only the people
know.
that invented it. Yeah,
I
you
watched them
think you
launch it
know,
in.
dude.
I know I watched them launch it into space
You've watched them launch it into space.
on
So
TV.
they've launched the ISS into space, and you've
Yeah,
seen that.
that's hilarious. Yeah, I
No,
watched a
you've seen
broadcast of
that.
them launching
What
it,
year was
and
that?
I don't know off the top of my head. I'd have to Google that. But
Why would you Google it if you were there?
I didn't say I was there. I just said that I
What year
saw it.
was what year was it when you what year was it when you saw it on TV?
Um, Let me look it up because I don't remember.
You got to look it up.
Yeah, why does that matter?
You don't know it?
No.
Because it would be something profound in your memory. You would be like, "Dude, I remember the year. It was like whatever."
Well, it
So
was
now you're looking something up
1998.
that you had it.
It was 1998. That was a long time ago.
Okay, so in 98 you saw something on TV that launched the ISS. Is that what you said?
Yeah.
What do you
Well,
remember
So
from
you're
that?
well, they launched the first piece of it
Biggie,
in 1998.
Yeah, go ahead. Go ahead, say
just
so.
a moment. So your entire faith is based on what you've seen on a screen, but you don't actually have firsthand knowledge.
It's not
Just to be
faith.
clear.
It's not faith.
Well, wouldn't it
Well, it
have to be
is.
What
since
is it?
you didn't experience any of this, but you saw it on TV?
Yeah,
That's the same.
you're
It's the
saying that
same for the
I
people that
literally
seen.
would have to go there to confirm that it actually
Yeah,
is real?
that builds the knowledge. That builds the knowledge that you would have if to support the claim that you know what the ISS is. That builds that knowledge. If you don't have it, you have at best an inference. That's all you have right now. I've seen it on TV. I've seen images, live streams. I've seen pictures, like all that stuff.
What's
And even
wrong
if
with
you
having
said
an
I saw
inference?
because it's not a knowledge claim. You can't say I know that ISS is there and what they're claiming it to be.
Do you know the
You can't
definition of
do
an
that.
inference?
Do you understand what I'm saying?
It's a conclusion reached on the basis of evidence and reasoning.
So what evidence do you have that they're putting humans in a vehicle up in that highest part of the thermosphere?
Uh, what evidence do I have?
Hmm.
Well, like I said, I watched the live broadcast of when they launched the first part of it,
Yeah, so
the
we're back
Russian
to
rocket.
videos and videos and pictures again.
Okay,
That's what
well,
people
let me ask you
that
a question
seen
though. How
that's
do you know that the Earth is
yeah, go
flat?
ahead. Yes.
How do you know that?
There's no measured curvature anywhere. Or
Have
so
you
I would
been
we would
high
say
enough to see to
well,
see whether or
let's
not it's a curvature?
let me well, I'm about to tell you, right? So we would say that the Earth is observed as flat, measured as flat, and navigated across as flat. So the flat plane of existence is what we say we reference. So if we're talking about flat, we're not just talking about an exact like the Earth is completely like paper thin. We're saying that the distinguishing features like elevation change from mean sea level would be gathered from a flat horizontal plane of reference. So the flat horizontal plane of reference would be gathered from mean sea level. So from mean sea level to any distance inland, that would be gathered as a flat horizontal plane
It's
from
Professor
mean
Dave,
sea
and I
level.
want to show you
So
the world.
the
He
vertical
knows a
point
lot
of
about
mean sea level,
science
all the way
stuff.
to, let's say,
Professor
I
Dave
don't know, you can pick any
explains.
point in the northern United States or
Throughout this
just
astronomy
anywhere on
series,
the
we've
Earth.
learned quite a bit
You would
about
use mean
every
sea level to then garner an elevation height or a change from mean sea level on a horizontal plane to where you're standing. So you would say, I'm, 1,400 feet above sea level. It just depends where you are, right? You would make a claim to a vertical elevation profile from where you are to where mean sea level is, connecting the 2 points from your feet all the way to mean sea level on a horizontal plane of reference. So we would be referencing a horizontal plane from mean sea level. And that's how we know we're on a different elevation on a horizontal plane. One horizontal plane, not many. So the point of mean sea level to where you're standing at right now, you could say, I'm at, I don't know, X feet above sea level. And that would be true because on a horizontal plane, that would be exactly the case. So connecting the two dots from a vertical point on mean sea level to where you're standing would be a horizontal plane of reference. So we're saying that the land has topography, of course, hills, valleys, and all that kind of good stuff. But we would say that can reference the horizontal plane by saying from mean sea level, that vertical point on mean sea level to where you're standing at that vertical profile, the elevation profile where you're standing would be a horizontal plane from mean sea level. That way you know where you stand in relation to mean sea level.
So you said that the flat Earth is navigated to be flat. So can you
That's
explain
correct.
why they have direct flights from Australia to South America? Shouldn't that be impossible?
Yeah, I would just say, atheist, you probably need to fix your mic. It's getting kind of
Oh,
robotic or something.
hold on.
But yeah, of course. So can you give me the
Sorry,
distances again?
sorry, that should be better. I'm sorry.
Yeah, it's better. It's better now. What was the distances again?
They have direct flights from Australia to South America. Shouldn't that be impossible on a flat Earth? Wouldn't because of the distance of the ocean would be? Wouldn't the planes run out of
No,
fuel?
yeah, no. So distances are gained from that flat horizontal frame of reference. So the horizontal plane of reference is always referenced from mean sea level to the distance of the travel. So let's say you want to travel from Australia to South America, I think you said. So that distance that's traveled would be got from let's say a horizontal plane of reference. So for practical purposes, the pilot knows that when he flies a plane, he's flying off of the assumption that he's flying over a flat and stationary plane. Now that being said, we're saying that all pilots are using the earth that way. They're not they're not flying over the earth as if they're going to negotiate over a curvature. They don't do that in their day-to-day job. I'm not saying that all of them are flat earthers. What I'm saying is when they use the earth at practically navigating across it, they're going to be doing so as if it were a flat horizontal plane of reference. So they're referencing a flat horizontal plane for practical purposes. So
Can you
that's how they
demonstrate
travel
that?
over the earth. For sure. They even the testimonies that come from these guys is that their assumption is they're flying over a flat and stationary plane to practically use it that way. But they would also claim they don't think the Earth's a flat Earth. They would say no, it's a globe. It's just locally we would refer to it as a flat plane and so on.
Well,
So
yeah. I
what I'm
mean,
saying the
I
thing
mean,
the thing that I'm
yeah,
saying
it
and the
appears
thing that I'm
flat
not saying,
locally, but
yeah,
that's
yeah.
not the
So what I'm
same as
saying
them
and what I'm not
assuming
saying,
it's a flat Earth on the entire
yeah,
global
yeah.
level and navigate and using their
No, 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 no.
navigational
Listen,
equipment on a flat Earth model.
yeah, they okay, pilots and mariners would use the earth as if it were a flat and stationary plane. I'm
No,
saying
they don't.
practically.
Can you and
Yes, they do.
can you link me
Atheists.
to this
They do it.
testimony?
Well, I'm just talking based upon the many years that we've been talking to these guys. But here's the thing: you could look up, like in the handbook of the flight handbook, like when they're learning how to, get to the bearings on how to fly a plane over the earth. They're taught that in one of the pages. I think it can be referenced. You can look at this. It's referenced as assumed as a flat and stationary plane. Even the militaries of the world will reference the Earth as a flat horizontal plane as a reference. They're not going to say overall that they're using the Earth, or that excuse me, that they're thinking that the Earth is a horizontal plane of reference. They're saying it's a globe, but they can use it that way because locally that's what it would appear to them as. Just
What
like you understand.
is that evidence for your side?
No, it builds an axiom. The axiom starts off as we observe the Earth locally as flat and stationary,
Yeah.
but to further bolster, yeah, to
If
further
you
bolster that, we, yeah,
sorry,
to further
sorry.
bolster that, we'd say it's also measured that way. So
No.
it's it, yeah, it is.
No, you can take
It is
measurements
atheist.
from
Yes, it
ground
is.
level and measure and come
So
out
let's
calculate the
let's
curvature of the Earth.
yeah. So that's interesting because that's where we're gonna go next. So if you say that it is measured to have some curvature, I would say the next question to you would be in what way has it ever been measured in history that it's been measured to have this drop over distance? Now, if you say there's a method you know of, then let us know what method that is so we can confirm.
Well, let's see. I don't know the name of it offhand, but I think there
Sure.
was a Greek mathematician that used the shadows from two sticks poles placed at different locations, and he used that to show that there was a curvature of the Earth based on um, the distance or the angle of the shadows cast.
Okay. Could that be done on a flat plane as well?
No,
Okay, let's test
Or
this out.
it would be different than the result that was gotten.
Okay, let's test this out. So if you have a light in your room, right? Let's just use a light, flashlight, for example. Any light source will do for this particular example here, this exercise. So if you have like an object, like let's say a soda can, or I don't know if you know what that is, a pop can, soda can, pop can. You have it in the center of your room. Put the light source right above that soda can. Well, it's not really going to cast a shadow because the light source is right above it, 90 degrees to the object, right? But take for example, if you move that soda can off into the left or to the right, you'd have a diverging shadow, which would be cast because the light source where it's at. The light source would be at a different angle from that object, casting a different shadow, a diverging shadow. You could do this on a flat surface or a curved surface. It doesn't really matter. But the case is you'd always have a divergent shadow depending on the proximity of the light. So if the proximity of the light is the difference from how you get a diverging shadow, then we could say that this can take place over a flat surface, over a curved surface. It wouldn't matter, but it's not going to be conclusive that it's a curved surface that it's happening on. So measuring shadow lengths still would not give us the conclusion that the Earth is a curving spherical shape. So that doesn't give us a conclusion because that's just an aspect of how light and shadows work, depending on how close the object is, the proximity to the light source.
Yeah, the
So,
sun.
like I said,
So
yeah,
it was Eratosthenes. I don't know if I'm pronouncing
mhm.
that right. Eratosthenes,
It's
and
fine. It's fine.
he lived in the city of Alexandria in Egypt, not Greece. And he read that in a city named Syene that was south of where he lived, on a particular day of the year, the sun's reflection was visible at the bottom of a well. And so that meant that the sun had to be
Sure.
directly overhead. But on that same day,
Yes.
in Alexandria, a vertical object cast a shadow. So he was using
Right.
geometry
Which is
to calculate the circumference of the Earth based on just a few
yeah. That's
things.
exactly what we. That's atheist. That's exactly what we just covered right now. So we covered the two examples of it happening on a curved surface or a flat surface.
Okay,
The
but just
surface
let
that
me
it.
finish what I
The,
was gonna say. So
okay.
okay, he knew there was 360 degrees in a circle. Okay, he could measure the
Hmm.
angle of the shadow cast in Alexandria, and he knew the distance between the two cities. The only unknown equation
Sure.
is the circumference of the Earth. So that's what he's solving for. So basically, the equation is you take the angle of the shadow in Alexandria, divide that by 360 degrees, and that'll equal the distance between the uh, the two cities, and you and yeah, I'm not good at math, but
No, I mean you're taking your
explain to me
your
how this would
tried
work on a flat Earth, though.
Junior,
right.
look at
So
the
if you
transfer
have,
back to you.
sorry, do you want to come in?
I just wanted to mention that
Uh,
to him, and also that Alpha is going to explain to you why the appeal to Eratosthenes' operation is not logically sufficient to prove the Earth is a ball.
Okay, well I'll
yeah.
listen, but I'm gonna have to
uh,
jump out soon if somebody else wants to talk.
Well, no,
we
I
can.
mean, yeah, the only thing I wanted to say, I guess, just to kind of finish this, I'm going to reiterate my point. If you're going to do a curved surface or a flat surface, it really doesn't matter. The only thing that we're doing here in Eratosthenes is moving an object closer or farther away to the proximity of the light source. So, as it were, with the well, 90 degrees above where the sun was shining, and of course, at a further distance, right, we'd have another city that we have diverging shadows. Well, on a flat surface, you'd still be having the same result of diverging shadows depending on where the object was according to the light source. So, as it were, when the light source was farther away from the diverging shadow, which we know at that particular time it was, so the whale was getting 90-degree sunlight directly down into it, so you could see all the way to the bottom. But the other one was having a divergent shadow. Now think about this: it could happen on both a curved and a flat surface. That the surface doesn't matter in this case for measuring those diverging shadows, because you can have diverging shadows. The only thing that you need is to move the object away from the light source. That's what causes the diverging shadows, not the sphericity of the surface or the Earth being a ball. That's not what causes that. What causes that is the proximity from the object to the light source. So there's no conclusion that you could draw that the Earth is a spherical body by saying that diverging shadows, measuring them, are going to give us a conclusion. Furthermore, the length that was used to measure the distance was the length of a regular stride of a person. So the length of a stride was the unit of measurement in which they used to measure the distance. So I mean, I don't know how accurate you think you can get with that, but that's what the claim was on that case. But like I said again, it doesn't matter because you could do this on a curved surface or a flat surface, but it's not going to be conclusive either way because all you're dealing with is the proximity of the object to the light source. That's all that's really changing here, and it changes the angle of the shadow depending on how close the object is to the light source.
I don't see how that would
Pretty
matter
simple,
though,
atheist.
because the sun being directly overhead of flat Earth would illuminate the entire plane, versus
Incorrect.
the Earth, how it is
Yeah,
curvature, or
yeah,
where you have day and
incorrect,
night on different
atheist.
sides,
Because
different hemispheres.
yeah, incorrect. Because right now in your mind, there's a specific cosmology that you have, and in the cosmology that you have, the Earth is massive. Or excuse me, the sun is massive,
Which it is,
bigger than the Earth. Well,
which it
you don't
is.
know that.
It,
So
yeah,
okay,
no,
so
we do know
we'll
that,
get. Okay, so let's test that information. How do you know that the sun is massive?
because you can, because we know based on the color of the sun how big the stars are, because it's a yellow giant. It's from
Okay,
spectroscopy.
okay, spectroscopy. But
Yeah.
how do we know the size of the sun is what they're claiming it to be?
Wait, ask him this question
Are you
and
saying that you
this.
don't trust NASA? I mean,
Looking at
maybe
color
as a
tells you
No,
its
it's not
maybe
size.
about.
that's not a
eh,
maybe
Yeah,
that's obvious
yeah.
to ask
No,
a
no,
flat
no.
earther,
It's
but
no, atheists. Check this out. It's not about trusting the information. We're trying to figure out what was the methodology in which they discovered that the sun size is what they're saying it is. So we're looking for a way that we can know that the sun size has been garnered by these individuals. So if we know that how they've done the method, then we'll be able to say, okay, well, I know the method how they know the sun size. But I'm asking you, do you know the method how they got the sun size?
yeah, they used a solar telescope aboard a NASA satellite that was in space. And
So the sun size was garnered by a telescope. What's the name of the telescope? What was the name of the mission? Do you know any of this information that you could support? Because it sounds
um
like you just made that up. So
oh, I made that up.
well, it sounds
The
like it. But unless
measurements
you
were made
support it,
at the University of
In
Hawaii
principle, that's not
at
sufficient. Just
Menal
staring at
Institute
the
for
sun.
Astronomy Science.
I mean, come on, let's address the actual premise. So, in principle, they sent a telescope up into the outer reaches away from the sphere and then stared at the sun. Does staring at an object itself inform you of its exact quantified size?
When it's an incredibly advanced instrument like a solar telescope developed by NASA, yes,
yeah,
you.
but you're saying things, and I don't know if you understand what you're talking about. How do you
Oh,
know that
really?
it's complicated? Do you know its inner workings
How
of that telescope?
how do I know that a solar telescope developed by NASA is complex?
Yeah. Yeah, no, yeah, because you're saying things, but I want you to describe how the methodology of using that specific instrument will tell you the size. Do
It
you know
seems
that?
to me like any claim I make, you just say, "How do you know that? How do you know that? How do you know that?"
Yeah,
Well, how
it's
do you?
important. It's important,
Well,
atheist. It's
how
important
you
for you
seem
to
to doubt
hold on,
everything
atheist,
that I'm
atheist.
saying, but
Yo,
you're
yo,
able
I'm
to
not doubting
confirm
it.
This
that the Earth
doesn't
is
Yo,
have to
fucking
yo,
flat.
okay,
be a
This is
hold
verbal
on,
this
hold
is
wrestling
on, hold
match.
on, hold
It
on,
bullshit,
would
hold
dude.
on,
apply to you.
hold on. So the only thing I want you to do is to think about what you're saying. If it's possible that you could back up the information that you just stated that the solar telescope is doing what it's doing, then I could see that you know what you're talking about. But if you're
Okay,
saying no,
I'll
they got a
send you a
really
link.
complicated telescope, and I tell you how does it work, you're like, oh, I don't know, man. They just got a
Yeah, I don't know
complicated
because it's
telescope.
so
Well, that doesn't
complicated. That's
support
why I
the
don't know.
information that you just said
Oh my
that
god.
that instrument can do what you say it does until you're able to describe the methodology in which it is able to garner a size from a distance. So that's what I'm asking for you to do. And I'm sorry that we're asking you to do this, but you're making the claim that you can know the size. So we want to know how. That's why it's important. They're relevant questions to what you're claiming, atheist.
Okay.
So if
You've
Well,
you
yet
don't
to
know
give a
how,
sufficient logic sequence with supporting premises, so we're waiting for you to do that. So just setting up a telescope, no matter how advanced, is not going to inform you of the size of anything.
I just like how
yeah,
I said that a solar telescope developed by NASA is complicated, and because I don't know how it works, that means that I don't know how it's complicated. That's why I don't know how
No,
it
no, no,
works.
no. That's you're okay. So you're making a claim about the size of the sun,
Wait,
and
wait,
you're
no,
saying they
I
have
was
a
going to answer your
complicated
question though.
You're saying that they have a complicated telescope, and I said, do you know how it works to understand that they are getting the size of the sun, or they could just be saying we're getting the size of the sun, but they're making inferences. Like you don't know anything about this. You're claiming things. And stacking a claim upon another claim is not going to help you get the answer until you know the methodology by which they're getting the size of the sun and how they did it. So if you don't know that, then how
I'm
can you make the
trying to
claim
answer
that they
your
are?
question. So the astronomers
Okay.
use stellar parallax to measure distances to nearby stars.
So
And
that's different than the solar uh, telescope that you
no,
just
that's
told
the
me, right?
method that they use with the
Okay, so
telescope. They
parallax.
use stellar
So what
parallax
is what is the baseline for what how okay, so parallax, but how do they know the sizes of things that are in the far distance to use that? Because we on Earth, parallax means something. So when you see a tree in front of a mountain and you see the tree moving faster than the mountain in the background, we know the size of the tree and we know the size of the mountain because there are things that are tangible in our reality here on Earth. Now, when you're using things off into the distance in the sky, you don't know the sizes of those things. So how can you tell me one thing is bigger than the other? Do you get it?
because stellar parallax is the apparent shift of position of a nearby star against the background of more distant stars.
How do
So
you know distance and size, atheist? That's what I'm asking.
because
You're
you can
you're
use something
comparing
that's
distance
called
and size to
standard
something.
candles. We know based on the luminosity of certain stars exactly how far away they are. Again, it's spectroscopy. And this
Okay,
is
so
extremely
because
accurate science.
because of the luminosity, we're gonna know the size. Is that what you're saying?
We know the distance because
No, we
and
know the distance.
we can calculate the size based on again the color. We know roughly the size based on a yellow giant versus a red giant, and our sun
Okay,
is a
these
yellow giant.
colors, yeah, yeah, these colors that are being used. I'm gonna ask you a specific
Oh
question,
my
and it's
god!
gonna probably throw a little. Yeah, it's gonna make it worse because if you say that we know what type of atmosphere that those objects or supposed objects are in,
Oh,
then we're
supposed
gonna have to
is
give.
the sun
Yeah,
supposed?
suppose it.
Yeah,
Yeah,
the
because
sun's not real.
here's the thing.
You're a
Do
fucking
you
idiot,
know it's
dude.
do you know if do you know if the sun's physical or metaphysical?
No,
Which
it's
one is it?
physical. It's there. The sun is there
How do you know that? No, it's
because I can
there,
see
but it's
it.
not saying. Yeah, so
How
what?
how
Is
do
it
you know your
physical?
how do you know your hand exists? Is it does your hand
No,
exist? Do I
no, no,
exist?
no, 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 no. That's not what I'm asking you. We're talking about the sun. Have you ever gotten a piece of the sun to say, look, man, this thing is physical. I got it right here. You don't
You
have
don't think
that.
the sun exists? You don't think the sun is real?
The sun exists. It's in the sky and it has
How do you know?
light.
How do you know
What
it
we call the
exists?
sun.
How do you know
But
that?
along with saying the sun is there, people are attributing attributes to the sun, like
No,
the
I'd like to ask you a
size,
question. I've
like what
answered a
it's
lot of
made of. Hold
questions.
on, hold on, hold on, hold on. You're attributing things to the sun that are not relevant. Because when I ask you, what's the size of the sun, you don't know. What's the sun made of right now, atheist? If you say it's physical, what is it made of?
It's made of hydrogen and helium.
Okay,
It's
how do you
working
know that?
on nuclear fusion, fusing one
How do you
element
know that?
into another.
How do you know that?
Because nuclear fission is a thing that we
It's
can
a thing.
observe.
That's wonderful.
Again, that's
It's
not a
wonderful. It's
not
wonderful
a
that
You're
it's a
asking
valid
me
thing.
how do
logic
I know that
sequence, dude.
science works because
Yeah,
it's
science works.
yeah, science works based on its
Junior,
track
that's not a
record.
Okay.
That's
valid
how we
logic
know it
sequence,
works.
dude.
The reason you have a computer right now and
Junior,
you can
you have
talk
to
to me is
stop
because
verbally
science
wrestling
works.
everyone else, dude.
No,
Let people
this is
reply
just
to
very
you.
irritating.
That's not a valid logic sequence.
Okay.
Okay? Just because nuclear fission is real does
Nuclear
not
fusion.
therefore inform you neither necessarily nor strongly that the sun is a humongous gas ball. That's
Yes,
not a valid logic sequence, dude.
yeah, it literally is. That's exactly how we know
But
How'd
I
you
just
the
verify?
properties
exposed
of the
how it's
sun
non
because
sequitur.
Yeah.
nuclear fusion is understood.
Okay. So how do you know that's
I
happening?
just
When
How
you
do you
look at
no
exposed how
no?
it's
I would
non
like to ask you a
sequitur.
question. I'm sorry for
You keep
no, you
interrupting.
haven't.
you keep disrupting the replies and the refutations,
Yeah,
dude.
I'm sorry.
That's not a valid logic sequence. Nuclear fission is real, therefore the sun is a gas ball? No, it doesn't follow. The sun could be something other than a gas ball, and nuclear fission is real. That's not a valid logic sequence. That's a non sequitur fallacy.
Nuclear fusion Do you think that nuclear fusion is real? That it's a thing that happens?
Good.
Can you stop whistling past the refutation I just said to you? So
Okay.
either expose how my refutation is fallacious or false in any way, or concede that it's a logically sound refutation and you don't have a rebuttal to it.
No, it's because it's a straw man. He asked me the properties of the sun, and I said that it's hydrogen and helium, and that
That's
nuclear
a claim.
fusion in the sun's
So
core
And
my
That's a
reply
was
was
a
claim.
a straw
fact.
man fallacy. So
take
you
anything.
You
so you
described my
weren't.
argument, and it was a straw man, and you
So
said
your
that that was
reply
my.
is that my reply is a straw man fallacy. So you didn't say that the sun is a humongous gas ball with nuclear fission happening?
I never
You
used the
didn't say
phrase
that?
gas ball, so no. Your description of what I said was incorrect, and it was a straw man. So yeah.
So you didn't say the sun is subsisting of hydrogen?
Yeah, I said that, but I didn't say because nuclear
So
fusion
then
exists
that would
that
stand
means
to
it's a gas
reason that it's
ball.
a
I never
humongous
said that.
gas ball, right?
No, I said that
Humongous
it's
ball.
made of helium and hydrogen
That's
and that
obviously not
nuclear
logically
fusion is happening in the
consistent.
core. Okay, well,
If it's a humongous ball of hydrogen, then it's semantically accurate to say it's a gas ball. So it wasn't incorrect. So it wasn't a straw man. Your
Flaming
critique
ball.
against my critique is
no,
refuted.
your description of my logic sequence was the straw man.
But it wasn't a straw man. You did say the sun is a humongous ball of hydrogen. That's your premise. That's what Alpha asked you. Then you gave your logic sequence and you just appealed to one premise, the fact that nuclear fission happens, therefore the Earth, therefore the sun, excuse me, is a humongous ball of hydrogen. That's
No,
non
therefore,
sequitur.
no, therefore, we can understand the properties of the sun. Not that the sun is a ball of
Okay, so
gas.
a red
And then
herring,
all he's asked me
because
is,
that's
how do you
not what he
know? How do
asked
you
you.
know?
He
How do you
didn't
know?
ask you, can we understand nuclear fission? He
Well,
asked
you
you,
don't.
how do you know the sun is a humongous ball of hydrogen with nuclear fission happening in it?
And I answered because of spectroscopy.
And your answer was non sequitur. The fact that nuclear fission happens and that the fact that any item whatsoever is any color and of any brilliance does not therefore inform you that it's at this distance and it's subsisting of these particular elements
Yes, it literally
and that it's
does.
this particular size.
No, it literally does. We can know
But
the
it
distance
literally
of star. No,
doesn't.
let
You
me
don't
answer.
apply that logic sequence anywhere else in the world ever. You don't just look around you and look at something's brilliance and know its distance. You don't look anywhere and look at something's color and it informs you of its size. You don't think like that. You have this special, ridiculous, invalid logic sequence that you apply to the stars.
Okay. I'm gonna answer my. I'm gonna give my answer, and then I really have to go because I don't want to say something rude, but I'm just gonna say that yes, we can observe the luminosity of certain stars and use stellar parallax and standard candles to know how far in light years they are. We can get the distance from luminosity, and it's a fact that you can use spectroscopy to see the color of a star
So you're just
and
making
know
claims and leaving.
its
Okay.
property.
You can make
You're
your
just
claims.
repeating the same things we just
Well,
make your
critiqued,
it's
dude.
make your
true. I don't
claims.
care.
Yeah, okay, then you
Yeah.
don't care. Then make your
Okay, so then
claim
you're
and
not
then
engaging in a
No,
debate.
I
You're
don't
just
care
chanting
because
at us now.
I'm just describing
your
actual
claim.
science, and you're
You're,
saying,
you
"Oh,
know,
that's a
it's
Yeah,
not
you're
claim."
science, it's
repeating
your
what you've
claim.
already been chanting and have been refuted.
Yeah,
This is
because
your
I was
claim,
right.
atheist. Right about what? Your claim?
Yeah, that
You haven't verified
spectroscopy
it.
is real and
You have
nuclear fusion
no,
is real.
spectroscopy is
Dude,
real.
enough with the
Listen,
chanting. Stop
spectroscopy
chanting.
spectroscopy is real. Therefore, what I see in the sun is real. You
Yeah,
don't. You're trying
yeah,
to correlate
yeah.
spectroscopy here on Earth. Yeah, you're trying to
Yeah, we can
correlate
use
spectroscopy
scientific
here on.
methods and tools
No,
to
you
learn
can
about the
do.
universe. That's not
No, 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 no,
like
no,
an
no.
outlandish
That's
thing to
bogus.
fucking say.
That's bogus. That's
Oh yeah,
bogus.
science
That's
is
bogus.
bogus then. You
Yeah.
don't believe in
No, no,
science.
no, no. What you're saying is bogus. I'm not saying science is bogus. What you're
Why?
saying is
Why?
bogus.
Okay, explain how
Because you
spectroscopy
can't
and nuclear
provide
fusion
evidence.
don't work
You're
then.
using spectroscopy to detect spectral lines here on Earth in a controlled environment to say that I'm going to shoot
No, it's done with
or
telescopes
look
in
up and
space, you
hold on,
fucking
dude.
moron.
All right, dumbass. What you're doing is you're looking at something in a far distance and then saying that the
no. Oh, you just
atmosphere
said it was from
that this
Earth, though.
yeah, no, wait, no, you're gonna
no,
wait.
you're wrong.
This is what's gonna happen. Yeah, no, here's what's gonna happen. You're gonna
Fucking moron. Well, that was fun. Yeah. I got a little heated. Well, hope you enjoyed.